Okay, so far we have created a material that looks realistic, it's three-dimensional and all that stuff. Now I want to create based on this material another material that would have some sort of a glow coming from the crevices and basically shining out as if there was lava flowing in. Okay, to show you this new or to create this new material based on my matte brick wall, I can copy and duplicate this material. So right click on the material in the content browser and then click on create a copy. And then change the name of this material to my brick glow, for example. This way I will have a material created for me that is based off the material that I had already made. If you double click on the material, you'll see that you have the exact same component that you had from your previous material. Now what I want to see here is in the middle or inside the crevices of the material, I want to see some glowing effects. Now let's see what component of these textures that we have can we use. We know that the texture sample that has the picture of the bricks, in the RGB component it has the color of the bricks, and the alpha channel it has specular components for the shininess around the area that the brick is wet. We also know that the alpha channel, the normal sample in the RGB channel, has the normal components for the three-dimensional surface, and then the crevices or the depth offset of the crevices is within the alpha channel. Now if you click on the alpha channel of the normal sample and add it to the diffuse texture, you will see that you will have a black and white area. So the darker areas represent the lower values of the alpha channel, or the 0 values, and the brighter areas right here represent the values that whose alpha channel is close to 1, meaning that the depth is higher. So if you think of this picture as a depth map, the brighter areas are the areas that are, in terms of the three-dimensional location, are higher, and the areas that are dark, or the areas that you see here in the crevices, they are the lower areas, basically the areas that belong to the cracks between these bricks. Okay, so we could use this information, or basically the alpha channel here, to add it to the emissive component, and basically that would be shiny. If we connect this alpha channel of this texture here, you see if I move the normal map here and I add the texture or the alpha channel directly to the emissive component, you see that the areas between the cracks emit very little light, and the areas on the surface of the bricks emit a lot of light. I want the opposite effect. So what I need to do is to put this value or this component, but the negative of this component, or basically 1 minus this component. What you can do is to right click in the gray area, from the math bring a 1 minus operator, and then add the alpha channel of your texture to the 1 minus. Now if you click on here, you'll see that the crevices now are brighter and the surface of the bricks are darker. If you add this component directly, you will see that the area between the bricks shines or is brighter, and the other areas are darker. Now we connect the diffuse component back in, and here's how your final material would look like. Now there's a little problem here, and that problem is that the area between the cracks look bright, but so does the area that is also outside of the crevices between the walls. How can I deal with this, and how can I make it look better? And basically to limit the shininess, just the areas between for the crevices. This can be done through a power expression. What I will do is that I will choose a base power, any number will do, and then I raise the 1 minus shininess or 1 minus emissive power to emissive component to the base power that I created, or to exponent that I created. When I raise the exponent, then I automatically limit the area. The reason for this is this 1 minus x is a number between 0 and 1. And from the math, if you remember, if you raise a number from 0 to 1 to higher values, powers, then that number becomes smaller and smaller. So to do that, right-click somewhere next to the 1 minus operation, and from the math, bring a power component. So this will create my power. What I need is the exponent. So right-click, and from the constant, bring a new constant value. This will give me the constant value for the exponent. Now, type in 1, and then get as input of the base from 1 minus, and the input of the exponent from the constant that you created. Now notice the power looks pretty much like 1 minus. Now let's increase this power from 1 to 5. When you increase it, you see that the power limits the shininess or the emissiveness down just to the areas that belongs to the between the crevices. And then when let's increase this to 10, and you'll see now the areas between the crevices look brighter, and the areas that belong to the bricks don't look as bright. And increase it to 20. Now you see that now you're limiting the shininess a lot more. So a number between 10 to 20, something like 15, might be enough. Now instead of the output of 1 minus operation or operator, just add the output of this power operator. And here you see that now your material has that shininess inside the crevices as opposed to outside of the crevices. You can change the feel of your material by simply playing with the contents here. And when you're satisfied with the shininess between your the walls, you can save the changes that you have here. Now let's apply this material to one of the walls here. So as you see here, now your walls have this shiny, bright color that is basically shining off of the crevices. Now let's play this level. I didn't save the material. And let's replay this. And here's how you see. To the left, there's the wall with the previous material, and to the right, there's the wall with the bright, shiny color. This color is just white because the value is between 0 and 1. You can multiply this, the value that comes off of your power expression here, with a constant 3 vector. So I right click and bring the constant 3 vector and choose a amber looking value for it, and then right click from the math, bring a multiply, and then multiply your power base with the color that you have here, and then add that to the emissive component. And now you see that your material is now shiny. If you save your material here, you have some shiny lights, basically, or colors coming off of the texture of the walls. Now, to make this shininess a bit more glowy, we can drag these expressions that we created to the left even further, and then multiply this value with a constant. And let's put 5 for this constant. From the math, bring another multiply, and add this new value that's now even more shiny and glowy, and add it to the emissive component. So your light is now glowing, basically. If you save it, you will see more glow coming off of the wall. So this is a nice feel for this texture or this material, basically, that I created. So I see this shininess coming off of the surface, or off of the crevices between the walls, which gives me that fantastic look for my window. Now I want to close here by talking about the dynamic materials and creation of the dynamic materials. And we get this further, we take this further next time for the next unit when we talk about advanced materials. For now, what I want to accomplish here is to make the glow that I see that comes from the materials to pulsate. How can I accomplish that? To pulsating this glow, you notice that the glow component that controls the amount of glow is this constant variable, which is 5. So if you increase this constant variable 5 to 10, it glows more. And if you decrease it to 0, it does not glow at all. So if I could change this pulsating value somehow that changes from 1 to, say, 50 or to 10, and then pulsate back to 0. So if I can change this glow to pulsate between 0 and 10, I could basically create the pulsating glow. How can I accomplish that? To do this, we can use math operations that are based on time. And one of those operations that's based on time is essentially sine. So if you right-click somewhere in the gray area, and from the math component, click on the sine value. This sine value, as time goes by, pulsates and varies between -1 and 1. Okay, so if I multiply the 10 here, so if you bring in multiply operation, and you multiply the 10 that you have here with the sine, you would see that this 10 pulsates between -10 and 10. However, we want this multiplication, instead of -10 and 10, to pulsate between 0 and 10. What you can do is that you can clamp the sine here to be between 0 and 1. So from utility, bring a new clamp and make the minimum and maximum values of the clamp to range between 0 and 1. So you can right click and bring a constant, which is 0, and then you can right click and bring another constant, which is 1, change the value to 1, and then you add the sign component. And this would clamp the value of the sign between 0 and 1. And then you can add the clamp here. Now right-click behind the sign, and from the utility, bring a time component. And then add this time to your sign. So now you see that your sign is multiplying between 0 and 1. And it's clamped between 0 and 1. And you see how it works. And then if you apply, instead of constant 10, apply the result of the multiplication, you see that your object or your light pulsates between the 0 glow and 10. Now to change the frequency here, you can change the frequency of the time or as the time goes by. So right click, bring another constant, and make this constant a smaller value like 0.2, and then multiply it to the time, and this would change your shininess. And if you save your results here, you would see that your material pulsates. One of the things that might not be the best practice here is to clamp the sign between 0 and 1, because that would automatically remove everything that was between -1 to 0 and clamp it to 0. That's why you see a lot of time your material is dark, and then it goes from 0 to 10, and then it goes back from 0. It stays dark because all of the negative values are clamped to 0. So to deal with this, I basically shift my value from -1 to 1. I shift it to 0 and 2, and then divide it by 2 to make it between 0 and 1. So here's what I will do. I will add 1 to my sign. So let's go to math and bring a 1 here and add it to the sign value. Now my sign ranges between 0 and 2 and goes back to 0. Now if I multiply this to the 10, when the sign is 0, the result is 0. When the sign goes to 1, the result is 10. And then when the sign goes to 2, the result is going to be 20. And then I can change my constant value here to 5. And now the sign value ranges between 0 and 10. And the pulsation occurs as I would like to see it. Now let's play this level one more time, and then I go back and I explain how this sign, my expression works here. Okay. Here's how the system works. You have a time component, and you multiply the time by 0.2. What that means is that you are decreasing the frequency that your sine function varies. Your sine function varies between -1 and 1. So it goes from -1 to 0, and then to 1, back to 0, back to -1. You add this to a constant value 1. That would change your sine output from ranging from -1 to 1. It ranges it from 0 to +1. And then you multiply the ranging value of 0 to 2, or to +2, to 5. So the output would range between 0 and 10. And then you multiply that with the shininess that is supposed to glow from between the crevices of your objects. And then you apply that to the emissive channel of your material. And that, in turn, makes your material present this pulsating glow from the crevices of the walls. Okay, with this, I will close up the content of this unit, and from this changing material that we created, we take it, and we try to manipulate our material expressions and material instructions to create more complex and more fantastic looking objects and materials. So go ahead and finish up the required materials for this week, and I'll talk to you next week for the next learning unit. Thank you.